Hi, everybody. I thought it would be great to give you a little bit of help for Tuesday night practice, December 1st, since I won't be seeing you on Wednesday and able to talk to you really about this. There are two problems I want to bring your attention to. The first one is this one right here, which was question number 3. And question number 3 said to solve and check each equation. So you were looking at this one, 4n plus 6 minus 2n, and equals 2 times n plus 3. So there's a couple of things going on here. First of all, we're going to take the left side first, okay? And in this left side, we're going to look at these three terms, 1, 2, 3. When we're looking at three terms, that means that more than one go together. So this term has an n and this term has an n. So these two are going to go together. So we have to think about that. I have a 4n and a minus 2n. So if I have 4 n's, I take away 2 n's, I'm left with 2 n's. And so this plus 6 is left over. So that's what's going to go here. So we're set on this side. Let's take a look at the other side. This is 2 times n and 2 plus times 3. If we think about what that means, it's saying that I have n plus 3 2 times, right? And I can see I have 2 n's and 3 plus 3 is 6. And that's what's going on here. 2 times n is 2n and 2 times 3 is 6. Now, one of the things that you should notice at this point is that both sides look exactly the same. So I want to stop right here and I want to kind of give it a bunch of different ways because I saw on some people's homework different things. So I want to kind of look at it different ways and see if I can help out. One way that people are doing it, and all these ways are correct. So let me start out with that. Every single way I'm going to show you right now is correct. It's just what you do with the answer is the question. So I had some people who started out subtracting 6 from both sides, and then they ended up with 2n equals 2n, and then they stopped. They weren't quite sure what to do with it at that point. I also had, let's go back, let's do it again. I also had people who decided that they were going to subtract 2n from both sides, which is great, get the variables together. And what happened, that left them with 6 equals 6. Okay, another interesting thing. The last thing I saw, let's get a different color here. The last thing I saw was I saw people take 2n plus 6 equals 2n plus 6. And what they did was they subtracted 2n from both sides, or they might have started with the 6's, and they got 6 equals 6, and they subtracted 6 from both sides, and they got 0 equals 0. You might have gone the other way first. Okay, so but what do all of these have in common? What they all have in common is this. They ended up with things that were exactly the same on both sides. Okay, now what does that mean to us when we have to write down an answer? What's the answer to the problem? When everything is the same, when everything is constantly the same, our answer to this is going to be all real numbers. Another thing you can write besides all real numbers, you can write that, or you can write infinitely, I like that word, many solutions. You can write either one of these down. What does this mean? All real numbers, infinitely many solutions. That means it doesn't matter what number I put inside here. Let me get my little magic pen here. It doesn't matter what number that I put in place into that n spot. It's always going to be the same. Okay, so this n here, what number I put in here, here, and here. If you tell me put in a 1 there, I put a 1 in all those places, and guess what? Both sides will be equal. You tell me to put a 3 into every place, everything's going to be equal. You tell me to put a 4, everything's going to work out to be equal. And the reason that we know that it's going to be worked out to be equal, because guess what? It's an equal sign right here. These are equal. These are equal. These are equal. This was equal. And because these are all equal, that's what's going to happen. Okay, so remember, we're going to focus on those two answers, that either we're going to pick all real numbers or infinitely many solutions when we get both sides are the same. All right, so now let's take a look at this one. Now this one here tells us that we're going to solve and check again. All right, and once again, we're going to take a look, and we're going to look at one side at a time. Over here, I have three terms, 1, 2, 3. And I notice that here I have a negative x and here I have a 6x. So these two go together. We're going to combine like terms. So when I do 6x take away x, I get 5x. Okay. Now on this side, again, there's three terms, 1, 2, 3, but the two things that go together here are the 1 and the 3. And 1 plus 3 is 4. So I'm going to write 5x plus 4. Now, one of the things that you hopefully are starting to notice is that the variables are the same, but the numbers are not. Okay, and because of that, that's why I always tell you, get the variables together. Some of you are focusing on the numbers first, which is fine, but then you get confused when it gets here. But if you stay with focusing on the variables, and you know that these look different, right? We can see they're different. Because they're different, we know it's not going to be this one. It's not going to be all real numbers because they're different. But what's going to happen is when I do subtract 5x from both sides, right, what am I left with? Well, what I'm left with is I'm a 5 on this side and a 4 on this side. And we're trying to say that's equal. This is false. Okay? 5 does not equal 4. If you think 5 equals 4, I'll tell you what. Every day for the rest of the year, I'll give you $4 and you give me $5. And by the end of the year, I'll be over $100 richer. Okay, so we know that's not true because that's a bad deal, isn't it? Because they're not the same. And because they're not the same, we know that there is no number in the world, absolutely no number in the world that I can put in place for x. I can say x is 1, x is 2, x is 0, whatever, it doesn't matter. There's no number in the world that's going to make this work. And because there's no known number in the world that's going to make this work, that's what we call no solution. Okay, you can, when we're typing it in the computer, you can write no solution. If you mistype it and say no solutions, don't worry, I'll catch the typo and still give you the point. But this is what I'm looking for. So when you're doing the quiz on Friday, if you come across a no solution problem, you can't just say no solution. I've got to see what's your proof. You're getting here that, hey, the sides are not equal. That's your proof. If you're getting to this one, what's your proof that it's infinitely many solutions? I should be seeing something that's like in the yellow, right? You should be getting down to this. I would hope you would get down to these bottom three, just getting one thing on each side and telling me why it's all real numbers. So I just want you to keep an eye out for these special solutions, okay? All right, good luck today. I know you've got a longer assignment, but just keep an eye out for these two. When things go special, then you know. Oh, I do want to add one more thing. When you guys are checking an equation, I'm putting something easy. I'm making this up on the fly. Okay, so let's say that you do something wrong, right? Let's do something wrong here. Let's say I want to multiply by 2 instead of dividing by 2. We know that's wrong, right? Okay, and I say x equals 8, and I stop and I say, hey, x equals 8, I'm done, Mrs. Dorlist, and you go to the computer and you put it in. But I tell you that you don't know unless you check, right? So people will go and check, which I think is awesome. But what's happening is, let's check this. 2 times 8 is 16, and 16 plus 1 is 17. These are not equal. So when you get something in the check, and we're talking about when we're checking, not solving, but the checking. When you get something on the side like this on the check, that does not mean this is a no solution problem. What this means is that the answer that you chose, this answer here, is not correct. That's what this check is telling us, saying, hey, something went wrong. So you need to go back and take a look and see what's happening. So when you do that and you say, oh, okay, I subtracted 1, that looks great because this is plus 1, I need to minus 1, that's good. But oh, this is multiplying by 2. I shouldn't be multiplying. What I should do instead is I should be dividing by 2. So when you go back and you rework the problem, okay, and you say, okay, this was wrong. I wasn't supposed to do this. That's why this is a wrong answer. So let me rewrite it here. 2x equals 4. I was supposed to divide by 2. Now I see that x equals 2. Well, let me go back in here and check and see if it's going to work now. Okay, so if I put a 2 in that spot, 2 times 2 is 4, and 4 plus 1 is 5, and guess what? This is equal, and that's why that is the answer. So when we're checking, yeah, when things are not equal, that's helping us to tell us our answer is not correct. But if we're solving, and everything goes away, and the numbers are not the same when we are solving the problem, it's no solution. So know the difference. Okay? All right. Good luck.